Welcome to the MSJC Internet Authoring Videocast.
Welcome to the CSIS 113B Lecture 9, covering basic GUI applications. Here's what we're going to take a look at in this lecture. We'll introduce you to the Swing and the AWT classes, which you need to import in order to be able to use the graphical components that we'll be showing you in this lecture. Then we'll talk about the fact that you need to create a container that we put all of our components into, so it's referred to as an application container. There's several types of them, and we'll talk about it. We'll introduce you to the JFrame. We'll show you how to extend your class to become a JFrame so that it inherits all of the properties from the JFrame class. And then we'll talk about JFrame properties as well. And we'll introduce you to an object-oriented programming concept referred to as a relationship, which essentially you'll see that when we extend our class to become a JFrame, it becomes an is-a relationship. So your class that you're creating at the point that you extend it to becoming a JFrame is a JFrame at that point. Then we take a look at the Content Pane. This is where you'll be placing all of your components. We'll also introduce you then to the JLabel, which is how you put text into your content. We'll talk about the various layouts for organizing the text in the components, and we'll also introduce you to fonts and colors. So there are a couple of classes that we need to have imported here to give us the ability to create GUI components within our Java program, and that is the Swing class and the AWT class, or the Abstract Windows Toolkit. The main thing that you want to know is that with the AWT, which is a prior class, a class that was used previous to the Java FX class that's now become more popular, and you'll learn more about that in the Level 2 class, is that all the components that we utilize from AWT, they look different on different platforms. So it depends on which operating system that the Java GUI application that you create, which operating system it's going to be running on will determine what the actual look of those components are. Whereas with the newer GUI components, the Java FX components, it replaces the Swing and the AWT and makes it more consistent. Your components are more consistent across operating systems that way. And Java FX, as I say, you'll be learning about in the Level 2 course. It was shipped with version 8 of the Java specification. And all the names you'll see too begin with a J, whether you're using Java FX or AWT. So for now, we use Swing and AWT in this course. And that's mainly because it's very mature, been around a long time, that means, and it's easy to use. So here you see a graphic that actually is representing that is a relationship that I was mentioning in the overview of what we'll be talking about. In order for you to be able to create a GUI app in Java, it has to be inside of a container. And a container is a component, and a component is an object. In object-oriented programming, you'll get these kind of hierarchies where you have a very basic class that has some of the basics that are needed for a particular purpose, in this case, creating an object. And then you start getting more concrete classes built on top of that. So component would extend an object, and it would have more detailed information, more specific information. Container now, that's going to be even more specific. And then you can see that from a container, we can build either a window or we create a window class from a container, or we can create a panel class. So if you're doing applications, use the window class. If you're doing applets, which have some security issues, then you would be creating panels. So we'll focus on the left-hand side here. So we're going to create a window, and then within the window we create a frame, and then the specific frame that we're going to create will be the JFrame. So notice how the arrows are pointing upward in that hierarchy there. That's the is-a relationship. So each of those components at the lower levels is a inherited class from the upper levels. We'll show you when we get into the guided practice how to go about extending your class to become a JFrame. You don't necessarily have to inherit it as a JFrame. It just makes things a little bit easier. The other thing that you need to know at this point about a JFrame is that by default, it is invisible, so we'll have to turn invisibility on when we create our JFrame. It has no size, so you'll have to give it width and height. And it has no closing behavior. You'll see that the close button within the window that gets created, when you click on the button, it'll close the window, but it doesn't stop your program from running. And so we'll show you how to set up a proper closing behavior for your JFrame. So on the far right of this slide, you can see that little graphic there. That is the actual Java window that gets created when we create an instance of a JFrame. And you wouldn't even see that unless you do the step that we're identifying on this slide here, which is to use the setVisible method and assigning a value or passing a value of true with that method. So you can see that if you look at the code example, we've imported the Java X, that's not FX now, that's the Java X package .swing .asterisk. So that gives us all the components inside of that swing package. And then in our main method, you can see we're creating an instance of JFrame. We're calling it frame. And then we apply, or we call the setVisible method and pass the value true to that method. So that's how we get it so we can actually see the window, see the frame. And then just continuing on from there, you can see underneath of the setVisible method, now we're calling the setSize method, passing two integer values to it. So that's 400 by 300, and that's in pixels. You could also use a dimension object here, which is an object that you would create that does define the dimensions of the object, I mean width and height, and then you would pass that in as the parameter to your setSize method. But we're just going to do it simply. We're just going to use the integer values. As I mentioned to you with regards to closing the window, there is a red, well, it depends on the operating system, but there's an X button, as you're used to seeing in most windows, that you would close. And when you click on that, the window will close, but the program is still running in memory. So you have four choices as far as the value that we use to modify the default method of the JFrame. And you can see that we use constants here. So either do _ nothing _ on _ close, which means don't do anything, which means require the program to handle the operation. You write your own code as far as when the close button is being clicked on. Or you've got hide _ on _ close. So that automatically hides the frame after invoking any registered window listener objects. And we'll get to event listeners a little bit later on. Dispose on close, automatically hide and dispose the frame after invoking any registered window listener objects. So again, you'll get more information about that when we start looking at events. You have to listen for events, and then based on the events that occur, then you write code to handle it. The one that you'll be using will be the exit on close. And again, remember, those are constants there, so they're all uppercase, each word divided by _. That's standard format for constants. You can also use a method to set the JFrame's title. It's the setTitle method, and we just pass in a string value to it. And if you see the graphic there on the right, based on the string value that we passed into the setTitle method, that's what's going to display up on the title bar. Now you can also pass the title in when you create a new instance of a JFrame. So that's what this example is showing you. The first line of code there in the main method you can see is the new JFrame being created, and then just inside of the constructor parentheses there you can put in a title, and that's a typo in there. It says tile in constructor. That should be title. So kind of backing up a step here before we assign all those properties to our JFrame, what we'll want to do is set up our class to actually extend from the JFrame. And it's the extend keyword that creates that is a relationship. And is a, as I mentioned earlier, just basically says that the class that we're inheriting from, we're going to get all the code that makes up that class and be able to use it within our own class. And so our class then becomes inherited from that parent class, and I don't know how else to say it. It is a JFrame class then in this particular case, and then we start adding more specific code to define our version of the JFrame. So it's becomes more concrete as we go down that hierarchy, if you remember back to that graphic. Now in that bottom grouping of bullets, it says that you can send all of the JFrame messages to this. So if you remember, we introduced you to the this keyword when we started in methods, I believe it was. So that references then the objects that are inside of that particular container. So in this case, inside of our class. And then the examples we have are this dot set visible to true, this dot set size. So instead of the JFrame like we did in the early examples here in these slides, you notice we're just using the this keyword in there instead of the instance name of that instance that was created of the JFrame, which was called frame. And so on this slide, we're just showing you here's where your class is in that hierarchical structure. We're inheriting from a JFrame, so that means that our class is below JFrame, meaning we contain everything from JFrame up above there. As far as code is concerned, we have access to all of the code that's built in each of those objects above it. So we're the bottom class, and our class is a JFrame, which is a frame, which is a window, which is a container, which is a component, which is an object. Just becoming more concrete as we move down the ladder there. This is referred to, by the way, as principal substitutability. And I would refer you to the Liskov substitution principle, which is one of the solid principles that we've talked about previously. We've talked a little bit in the past about creating constructors. So when we're taking and using classes and we create an instance of that class, it's the constructor method, which is kind of like the main method of a program. It's the constructor method for the class that is utilized to actually build the class. So if you think of the class as the blueprint, you can think of the constructor as the factory then that builds that class into an object. So there's three characteristics with regards to constructors. It must be declared as public. You can make it private, but then the object would not be able to be publicly created. So just for now, the access modifier for the constructor should always be public. And then you must have the name as the class. So whatever your class name is, that's what the constructor name is, with a pair of parentheses after it. And it will have no return type, not even void. So it's very much like a method header. You'll have the access modifier public, then you'll have the name of the class, pair of parentheses, and then curly braces to put in all the statement blocks that will run when the class is instantiated, because that constructor will be the method then that runs and builds the class into an object. So here is our example of a constructor. So you can see that we've got a class which is GUI app. It's extending from JFrame. So when we create an instance of our GUI app class, we essentially have a JFrame object with more specific information, and that specific information is defined there in the constructor. So the constructor is that what you would normally think of as kind of a method header, public GUI app parentheses, and then the statements there, setting the visibility, setting the title, setting the size, and then setting that default close operation, which is the JFrame.exit on close is the recommended one for what we'll be doing at this point in time. Now realize when we do this, we're going to need to make an instance of our class. We'll need to create an instance of our class, an object of our class. And so look at the main method at the very bottom there. You'll see that we're using our data type, which is GUI app, so that's what the class name is. We're going to name the instance GA in this example. And then that'll be equal to new GUI app parentheses. So that's the actual call to the constructor. That's what says make a copy of all that code, create an object of it, and assign it the name GA. So the content pane is the window area where we add our GUI components. We must get a reference to it. We'll show you how to do that in the guided example here. But also you have to have imported the AWT class or package of classes in order for us to be able to have access to a content pane. So you got to remember now that we've created an instance of our class, which we showed you in the last slide there. So we're referring to its contents with the this keyword. And so if you look at the first bulleted red text there, you'll see that we're creating of container type a name content that is being assigned the this.getContentPane. So that's the message or method that we're calling to create the content pane, and then we'll reference it as content as we use it within and throughout the program. Then the next grouping of bullets down below there you can see is we're actually adding components to that content pane. So here is an example of creating a JLabel, and you'll see that in all of the statements that we're using here, we're always creating instances or new objects from these classes. So these are all classes you have to remember inside of AWT. We have to create an instance of them to be able to utilize them. So we start out, we want to add a JLabel into our container. We use the statement JLabel and then the name LBL equal to new JLabel, and then we're passing that title to it, in this case Hello World. Now that creates the instance of the JLabel as LBL, but now we still need to add it into our content pane. So we use the keyword that we assign, the name that we assign to our content pane, which is content, and then we use the add method, so .add, and then inside of the parentheses what we want to add to the content pane, which is our LBL object. So JLabel, as you saw on the last slide there, is the simplest component really to put onto the screen. It is a swing component. It's used to place text on the screen, and you can set the background, the foreground, and then also that would be the colors, and then also the actual string text that you want the JLabel to display, and then also we can apply different fonts to it and font sizes and font styles. So in order to have access to that JLabel, we need to have access to the Swing library, and so you can see we have the import statement there, javax.swing.asterisk, and it's created as I discussed in the last slide. Just like any other complex type, we have to create an instance of it. In this particular example, now we've got an instance named MyLabel, which is going to be a new label with the Hello World text being passed to it as the title. All right, I shouldn't say the title in this case. This is the actual text for the label, the block of text that's going to be placed inside the content pane. Now, if you didn't want to pass the text value when you generated the instance of the JLabel, you could add it after the fact by using the setText method. JLabel also has several overloaded constructors that allow you to set the alignment of the JText within the content pane. So you can see the examples here of JLabel dot, and then again using a constant there. So all cap center, or all cap right, or all cap left. Layouts are used to position the components. So layouts are used to position your components within the content pane, and it supports auto sizing based on screen resolution. In other words, the position of the components will adjust as you increase or decrease the size of the window that contains them. And we'll look at some examples here. We'll look at the border layout, the grid layout, the flow layout. We won't be talking about the spring layout, but just you should be aware that that exists. And we'll show you how to set that up here in a moment, but just know that border layout is the default layout within Swing. So in the case of a border layout, you can organize the screen into 5 different areas. You can see that in the graphical example there. We've got north, south, west, east, and center. And that might seem intuitive, but the reality is, especially with the west, center, and the east there, it kind of depends on how many components you have that are on the same line as to whether or not they actually align specifically as you would see in the graphic there. And we'll see that more when we get to the guided practice. So here we are adding components then to an area of the border layout. So in the code example at the very bottom there in the red box, the red bordered box, you can see we've created our content pane. Then we create a JLabel, and then when we add the JLabel, which is LBL, into the content pane, you'll notice we add a second parameter there in the add method, and that's where we actually define the border layout area. So border layout is the property dot north is the value. In this example here, we're doing all of the areas, and you can see that by default, everything does align to the left. So if you look at north and south, for example, you'll see that they are aligned left since they're the only component within that particular area. And then the code block on the left, just showing you again, creating all of the different labels and then applying the areas as part of the second parameter there for the add method of our content pane. Grid layout is another style of layout that we can use. It divides the content pane into rows and columns. It's determined by the value passed to the constructor. So you can see in the example there, we create a grid layout that's named layout. And then when we call the grid layout constructor with the new operator there, we're passing to it how many rows, which is 3, and how many columns, which is 2. So just remember that rows is first and columns is second. Then once we have our layout, you can see we use the content pane object and its set layout method, and we pass to it then that grid layout that we just created on the line up above it. And we could do this all in one statement if we just did content.setLayout, and then inside of the constructor, or inside of the set layout method, we pass as a parameter a new grid layout object with the parameters of 3 and 2 if we wanted 3 rows and 2 columns. In this code example, you can see we've created several JLabels with the values, the text values 1, 2, 3, 4, 5, 6. Then we create the container. We're going to name it content. We're using the this.getContentPane to do that. And then you can see we have the constructor for our class, GUI app. Inside of there, the first thing we do actually is call a custom method that we created down below there to create the window for us. So since we always have to set the title and the visibility, the size, and the default close operation, that's a good idea to stick that into a method and then just call that method whenever you want to have the those basic steps created for the window. Once the window is created, then you can see we add to the content pane the new grid layout that's going to be a 3 by 2, 3 rows by 2, and then one by one we add each of the labels that we had declared up above. And you'll notice that in the grid layout, you can think of it more like a table, how all of the elements are spaced out there automatically by the GUI. When you're using a grid layout, you can also use HGAP and VGAP to set the horizontal and vertical gaps between the rows and the columns. So what you have to understand is that again, the window size is going to be changing depending on the resolution of the device, depending on the size of the window. And so what happens is everything swells to fit their space based on the amount of available space. And so if you want to be a little bit more specific about the spacing between your elements, and again, this is all going to be dynamic depending on the resolution and the size of the window, but you can increase the horizontal gap, increase the vertical gap if you'd like to. The way that we do that is we just add 2 more integer values. So if you look at the red text there, the red bulleted text, you can see we're creating a new grid layout of 4 rows and 3 columns with 10 pixels spacing between the columns and 2 pixels of spacing between the rows. So the third value, the third parameter you see there is the HGAP. The last parameter is the VGAP. We won't be getting into JButtons at this point, but the graphic that you see here was created using JButtons and just showing you the spacing that you can create between these elements, these components, using the HGAP and the VGAP values. Flow layout is our third type of layout. It's probably the simplest layout. It places components on the screen one at a time based on their size. Starts from the left, works to the right, and starts from the top left-hand corner. If a component does not fit on the line, then it's just simply moved to the next line. So if you think like a Microsoft Word document, as you're typing out words and you get to the width of the page and then it just moves it down automatically to the next line. Or if you've ever done HTML development, then you know how that works as well. Allows you to specify the alignment. So you got left, so that's left align, right, which is right align, or center, which would be center align. And so we're creating an instance of the flow layout, calling it layout in this example here, and then in this particular case for the constructor flow layout, we just simply pass the alignment value to it with flow layout dot, and in this case align left, so just all uppercase, constant again, all uppercase left. So fonts are created the same way as other complex objects. We're going to create an instance of it, and you can see that the font has a constructor that takes the name of the font, so that's your font family, the style of the font, so that's bold, italic, normal, and then also your size, which will be in point sizes now. So this is not in pixel sizes, this is in points, which is a standard typography measurement. So now when we assign a name to our font, we can use any name of any font that's on our computer, on our system, but you have to realize that your application is not going to only run on your computer, it's going to run on many other devices out there. And so the font family is dependent on being installed on the device where your application is going to run. So it's really best if you stick with the 3 standardized or built-in fonts, which are serif, sans serif, and monospaced. That way you can assure that those particular font types will be available to any device that your application runs on. As far as style goes, you can see you have the choices of bold, plain, or italic. And if you want to combine 2 of those together, which generally would be bold and italic, you can see you just use the plus operator in between. So here's an example of applying a font to a JLabel. So the first thing we've done here is to go ahead and create our container. Then you can see we've got our JLabel, which is named label font. And in the constructor then for the JLabel, we have passed the font name, the font style, and the font size. So this might be a little bit confusing when you look at it because we're creating a JLabel here. When we create the new JLabel, we're passing to it a string. So this is not actually determining the size of the font, right? This is just simply text that we're going to use or display on the screen to remind us what we assigned to our font. So in other words, we're going to create a font that is monospaced as far as the name is concerned, bold, 24 points. But that's, again, just the text that's actually going to be displayed on the screen. That's not the creation of the font itself. Down below, under the green commented text, there you see is where we actually create the new instance of a font. And we're calling it FNT1. Here's now where, after the new keyword, we call the font constructor, and we're passing to it the actual font name, monospace. So notice that's passed as a string value. Then the constant font.bold, and then the last parameter, the third parameter there, which is the 24-point size. Now down in the constructor for our class, which is the GUI app constructor there, you look down towards the bottom, before you get to the comment, just notice that we added the JLabel. It was called label font, right? So we used the add method for our content pane, and we passed to it the label font, so that's the JLabel itself. Now label font, which is our JLabel, we use its set font method and then pass to it the font that we created with those 3 properties, the font name, the font style, and the font size. If you've ever had a design class, you might be familiar with colors. Colors come in various different models. And so when we're writing programs that need to change the colors of our various elements or components, to start with, what you'll see is that when it comes to Java, the components like the JLabel, we can set the text color, which is considered to be the foreground color, or the background color. If you've done any web development, this is probably intuitive to you that the foreground color is the text color, and then the background color is the color of the element that contains the text. So there's a couple of ways for setting color. We can use one of the built-in constants. You can see the list there: black, blue, cyan, dark gray, gray, green, light gray, magenta, orange, pink, red, white, and yellow. So those are the constant names on the left. Those are the ones that you'll actually use for assignment, and then the column on the right is just the text that represents the actual color. So here's an example using a built-in color. Just jump all the way down to the bottom of that code there, and you can see that for the JLabel, we are using the set foreground method, and then what we're passing to it is the keyword color dot and then the constant, in this case, magenta. Graphic on the right then just shows you what magenta color looks like when assigned to the JLabel. So as I said earlier, color can be defined in many different models in the computer science arena. One of the most common ones is the RGB color model, because your TV and your LED screens, basically that's what they use, is red, green, and blue to mix things up and create all the different colors in the rainbow. But there are others. If you're in the printing world, you use CMYK. If you're in the design world, like working in Photoshop, hue, saturation, and luminance, or HSL, is quite popular. And there's also lab, which is luminance, and then A channel, B channel. But I'm digressing. We're going to focus on RGB here. And two ways then of representing the RGB values, one as whole integer numbers and the other is as percentages. So you'll see at the very bottom there, we're looking at the whole numbers. They can range, they're integer values, and they range from 0, which would mean that the color is completely off, all the way up to 255, which would be maximum or full intensity of the color. So varying intensities of each of the three values, RGB, is how we get the mix then to create all our different colors that we might choose to mix. And if you're wondering why, if you don't remember back to your binary math, 2 to the 8th power, you have the numeric range of 0 to 255, and so RGB color uses 8 bits unsigned to represent the actual values within the CPU, or the graphics card, really. So then if you wanted the color red at 100%, then it would be 255, and then if you want the green color to be completely off and the blue color to be completely off, they would each be set to 0. So in this case, all we've done is turn on red to full intensity, and so you're going to get that color. If you've never dealt with color mixtures before in RGB, it takes some getting used to, because you're used to using, if you're used to using like paints, watercolors, printed inks, things of that nature, those are all reflective color situations, which means when you mix, say, yellow and blue, we know that's how we get green. Well, it's a little bit different because we're dealing with projected light at this point, which the RGB model represents. So it takes a little bit of getting used to actually get the colors you're looking for. Unfortunately, there's a lot of tools out there that we can use, like Photoshop, for instance, to come up with those color values. So here you can see we're creating a color object. If you look under the green commented text there, you can see we've defined our type as color. We're naming it my color, creating a new instance then of the color class, and then passing to it the values of 125 for red, 100 for green, and 80 for blue, which gives you that kind of reddish brown color that you see on the right in the window graphic. So once we created that color, which is named my color, just jump now down to the bottom of the code there, and you'll see that we just, to our JLabel, we're going to use its set foreground method and then pass to it the my color object that we created, which had that color mixture assigned to it. Instead of using the 0 to 255 values, we can do it as percentages. So from our previous example there where we had 125, 180, that would be in percentages 0.49, 0.39, 0.31. So in other words, 49%, 39%, 31%. And the reason we're using floats here is because numbers by default in Java are considered to be doubles, and then we need to make them floats. So make sure that when you're doing percentages that you always add the F there to indicate that that's a float value that you're passing. So background colors work the same as far as the model available to us, the built-in colors and the RGBs, and then how we mix them, whether they're the integers or the percentages. And so when we're saying background color, we're referring to the background color of the component itself. So in this example, we're using the JLabel component. So you can see in the code example at the bottom there, We're setting up a JLabel named LBL Hello. And one of the important things too here is that the opacity of background color on our components is always set to 0. In other words, it's transparent, which means that the background of whatever the component's laying on top of, which is usually the content pane, whatever that color is, that's what comes through there. So obviously you wouldn't by default want to always see the background color. If you're creating a text element and putting it into your content panel, you wouldn't want to always have a background color. So the default is for it to be transparent so that you just see the text initially. So if you do want to see the background color, you need to use the set opaque method of the JLabel, turn it on to true, and then go ahead and assign the set background color, or just set background method, pass to it a color that you have previously created in your code. And here's an example then of the background color that we applied in that last example, which was a yellow color. So as a review of Lecture 9, we took a look at the Swing and AWT classes, and the most important thing there is to be sure that they're imported into our program. Then we took a look at our application containers, showed you how to set up your content panes, and then added JFrames and assigned the JFrame properties that are used by default. It's preferred that you extend your class to be a JFrame to make things a little bit easier on you, and just have all of the classes and components that you need to make up your GUI applications. We talked about relationships. We showed you how to implement the content pane. We showed you how to implement and modify JLabels. We talked about the various layouts that you can use for positioning your components within the content pane, and then we showed you how to assign fonts and colors to, specifically in this case, a JLabel. So that's the end of Lecture 9. Until next time, happy coding! If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.